Reagent is a minimalist Clojure wrapper for React. It exposes all React APIs, including hooks, and is one of the most popular Clojure projects. This chapter is a theoretical introduction to Reagent. The code in this chapter doesn't apply directly to the tiny Canva project. Reagent uses hookup to define React components. Components are vectors where the first element is the element to render, second element is the props map, and the third element is the child tree. Unlike React, we can use the keyword class instead of class name to define CSS classes. Also, these are just plain vectors, so everything that we have learned about data manipulation will work here. Like in this example, we used when to conditionally render a component. Functional components are vanilla Clojure functions. Reagent converts these functions into React components and renders them. To test the heading function out, we can move its definition to app core namespace and then swap it in place of hello as an argument to our render function. As soon as you save the file, Shadow Watch will hot reload the code in the browser. We can also use reagent.code/create element method to create a functional component instead of hookup. This might be helpful in advanced use cases like animations. Native DOM elements are rendered using keywords like div or span. Custom components can be rendered using symbols. If we want to use the heading component that we defined earlier, we can use heading symbol as the first element of the vector. There are two kinds of reaction people have after reading this code. You either go, yeah, that's simple, hiccup, it's easy. Or you wonder why square brackets are used for custom components. Since heading is a plain Clojure function, we should be able to invoke it using parentheses, but we use square brackets instead. You can use round brackets too, but it is advisable to stick to vectors until you understand what is happening under the hood. Reagent transforms hiccup forms into React components using create React class. If parentheses are used instead of square brackets, the heading function will be called and its output will be placed in the cart component. That is, the heading component will lose its identity as a React component. It will also lose the properties of a React component, like the ability to be memoized or the ability to have local state. If square brackets are used, heading function will not be called. Instead, Reagent will package it into a React component and place it inside the cart, preserving the properties of a React component. React's ecosystem is exceptional. There are tons of high-quality open-source libraries like Design and Material Design. With Reagent and Shadow, we can use these components easily. Reagent's adapt React class function converts any React component into a Reagent component. There also exists a convenience method for third-party components. The symbol $sign can be used as the first element of the vector, followed by the component to render. We can rewrite our example as so. The special literal $sign is a shorthand to create React fragments. The following two forms are identical. .heading and #main are shorthand versions of class heading and ID main respectively. Reactive atoms, also known as atoms, are special atoms that tie into a component's lifecycle. Here we have defined a counter component that accepts a reactive atom. This component can be rendered using the form counter or atom 0. Each time count changes, the component will be re-rendered. When we generate an app using create CLJS app, a component similar to this one is generated automatically. You can check its source code in app.hello namespace. A atom behaves just like a usual atom in terms of the API. Reagent's reactive atoms can be shared across components. In this example, we defined the state at the namespace level and had two components, form and val voucher, read and write the state. If you are not able to follow along the atom usage, we suggest rereading the chapters on atoms. The get function used for value prop gets the value for a key in a map. If no value is found, the default value, the third argument, is returned. In this case, an empty string is returned. Reagent components are class-based, and there is no easy way to use hooks in a class-based component. But we can expose reagent components as functional components using asElement method. This lets us consume hooks. In this example, we defined a view that depends on React's useState hook. Instead of returning a hookup form, we wrapped the hookup form with our asElement method. The important point to note here is that the view is not a functional reagent component anymore. Instead, it is a proper React component now and needs the := or adapt React class to work correctly. If we try to render the view directly, it won't work. Just like adapt React class converts a React component into reagent component, Reactify component takes a reagent component and converts it to a React component. This is good for interop or writing libraries. You can create a part of your UI layer in CLOJUREScript and expose it to your React app as an NPM module. You need to write your functions in a different way though. React functional components accept two arguments, props and children. React calls your functions for you and passes the correct props. Here we have rewritten the heading component so it could be reactified. Notice how it is accepting a props argument instead of text, and then we destructure props to pull out the text. The CLJS to JS conversion is needed because React heading exists in the JS domain. Clojure maps don't work in the JS domain. Strings, integers, booleans, and other simple data types too. Compound data types like maps, vectors, lists, etc. need implicit conversion. The CLJS to JS function can also be replaced with the #JS literary form. Since React heading component exists in the JS domain, reactive atoms will not work. In this chapter, we walked through reagent basics and learned about various ways of creating components. We saw how to consume third-party components. We also learned about reagents' reactive atoms. Although we covered the functionality we need the most, a lot of reagent features remain untouched. We will uncover the API more as we build our application.